sequestration and greenhouse gases mitigation. The floor is for you.
Just for a point of order, we'll need the 12 minutes presentation, and we'll give the chance for 2 or 3 minutes for questions. Thank you.
I will try to do my best. So, how it works? Show me how it works? Yeah, but it's actually, I not to make it bigger. It's okay? Okay, thank you very much, dear colleagues and friends. Dear co-chair, thank you very much for your attendance. My presentation will be on the role of date palms and over the salt in carbon sequestration and greenhouse gas mitigation. As you know, it is a very, very new topic and needs still a lot of research. No, it doesn't work. The green one? No? No, yes. So I divided my conference. Sorry, I would like to be just here. I divided my conference in 6 points. The first point will be a short introduction, then CO2 and its evolution in the atmosphere. The third point will be on carbon sinks. Fourth, CO2 sequestration by dead palms, CO2 sequestration by oasis soils, and then a final conclusion. Just a brief introduction. As you know, the increase in concentration of greenhouse gases such as CO2, methane, etc., emitted from industrial and agricultural sources, trap heat in the atmosphere, and results in many phenomena. Vegetation, particularly perennial woody species, provides a natural means to capture and store atmospheric CO2. Among such species, Phoenix dactylifera is uniquely adapted to extreme aridity, high temperature, and poor soils with other trees. Date palm has an effective carbon sinks by absorbing carbon dioxide from the atmosphere and store it in their biomass and in soil. So this capacity makes them a valuable tool for combating global warming, particularly in arid and semi-arid regions where they grow despite of the very difficult conditions. What is the situation of CO2 and its evolution in the atmosphere? As you can see, CO2 is the main anthropogenic greenhouse gas on our planet. It comes mainly from emissions from fossil fuels, some industrial process, deforestation, intensive agriculture, and natural activities such as volcanic eruptions. These are the main sources of CO2. CO2 emissions now account for about 90% of all CO2 emission from human activities. The lifetime of CO2, and it is very, very important, in the atmosphere is about 100 years. Then vegetations, soils, and oceans absorb about half of all CO2 emissions, and the rest accumulates in the atmosphere and increasing global warming. The Intergovernmental Panel on Climate Change anticipate a warming between 1.8 degrees centigrade and 4.85 centigrade by 2100 in the event of doubling the CO2 concentration in the atmosphere. In the worst case scenario of the IPCC, it is possible to easily, as you can see in this graph, exceed 1,000 ppm by the end of the century, or even 2,000 ppm in the following century to reach 5 degrees centigrade to 8 degrees centigrade more than before the industrial area. And according to the IPCC, we continue to head toward the wall. The carbon sinks. I will just describe the three main carbon sinks: plant, salt, and oceans. A carbon sink, which is the definition of a carbon sink is a type of carbon pool, a kind of basin, that has the capability to take up more carbon from the atmosphere than it releases. The natural carbon sinks are plants, soils, and oceans. These three carbon sinks absorbs about half, which is very, very important, half of all CO2 human emissions. What about plants? As you know, carbon sequestration. When you talk about carbon sequestration refers to the process by which plants are absorbed carbon dioxide from the atmosphere during the photosynthesis process and store it as carbohydrate in the biomass. The amount carbon sequestered varies, of course, widely with many factors such as plant species, age, climate, soil type, and management practice. Let us just give you a very important figure. About 30% of CO2 emitted by human activities is covered by plants through photosynthesis. 1/3 of the CO2 emitted by human activities are sequestered by plants through photosynthesis. And I will just give you here the formula of the photosynthesis. Now, what about the carbon sinks, soils? Soils, briefly, when the plants die and decompose, living organisms such as fungi, bacteria, earthworms, transform them into organic matter. Carbon becomes locked up in the soil through many biological processes that I have enough time to describe this process, but these processes are described in the slides. This organic matter, rich in carbon, is essential to plant nutrition because it retains water, macro, and micro elements which are essential to plant growth. Oceans. Oceans are carbon sinks. Carbon dioxide easily dissolved in soil, in seawater. Kelp takes up CO2 via photosynthesis, as you know, and the dead material sinks, and carbon is sequestered in the deep sea. It is just a brief, very, very brief description of oceans as carbon sinks. What about sequestration by the palms? Let us see the carbon sequestration by sub-tree species. I tried to choose some important tree species and show how important is this carbon sequestration by these three species. You can see that, for instance, eucalyptus. Eucalyptus, the average carbon sequestration rate is between 6 and 10 tons CO2 per hectare and per year. What about date palm? Date palm is just 2 to 6 tons of CO2 per hectare and per year. So date palm photosynthetic activities, as you know, varies, of course, with age, soil fertility, irrigation, environmental conditions, etc. Major date palm between 15 and 25 odd can fix approximately 2. The 2 6 ton are for an average of major date palms, and they sequester between 2 and 6 tons of CO2 per year. Now, let us talk about the CO2 sequestration by date palm in my country, in Morocco, and in the world. I will start by Morocco. The population of date palm in Morocco has seen, as you know, a significant decline from an estimated 15 million trees to approximately 4 million now, largely due to drought, water scarcity, fires, and also devastating the biodisease. This has resulted in a sharp reduction in oasis area from about 150,000 to 60,000 hectares. In response, and this has been developed this morning, Moroccan plan has decided to date palm sector as a priority for the revitalization of this sector with initiative focused on protection, research, and planting millions of new trees.
May I ask you, please, to conclude in
Yes,
1 minute?
just 3 or 4 slides. Sorry, but I had 15 minutes, not 12 minutes. And I prepared my presentation for 15 minutes, and I will take my 15 minutes. Okay? So in Morocco, high density oasis plantation, this is the area. The sequestration of the CO2 with it's between 180 tons to 330 tons, and okay, I will go worldwide, so I will say I have no time. So CO2 sequestration by oasis soil. Sorry, I have to go because the chair said I have not only 12 minutes instead of 15 minutes. But CO2 sequestration by oasis soils. What are the mechanisms? The mechanism sequestration by oasis soils refers to the ability of soils in oasis ecosystem, arid and semi-arid region to capture and store atmospheric carbon dioxide. And it is just an example of CO2 sequestration in the Tafilalet oasis. Date palm grows about 245 tons per hectare, cultivated field 207, and desert martin soil 168. As you can see, the sequestration in date palm grows is more important than in cultivated or desert martin soils. This is one of my last slides. I would like just to talk in 1 minute about the 4-per-mill initiative. Many of you know this initiative. Soil represents an enormous potential for carbon storage. The world's soil contains 2 to 3 times more carbon than the atmosphere. Greenhouse emissions from fossil carbon are estimated of 8.9 gigatons, and the global estimate of soil carbon stock is 2,400 gigatons. Taking the ratio of the global emission and total organic, we arrive to a percentage of 0.4% or 4 per mil. The 4 per mil soils for food security and climate was launched in the COP 2021 with an aspiration to increase global soil organic matter stocks by 4 per thousand per year as a compensation of the global emission. This is my conclusion, Mr. President. So, the increase in concentration of greenhouse gases, and particularly of CO2 in the atmosphere, has a wide range of effects. Rising sea levels, increasing frequency and intensity of wildfire, more extreme weather events, etc. Vegetation, soils, and oceans absorb about half of all CO2 emissions. The rate accumulates in the atmosphere and causes increased global warming. The date palm is a vital crop in arid and semi-arid regions, particularly across North Africa and the Middle East. Beyond its economic importance, it plays a significant ecological role in absorbing atmospheric CO2 and mitigating greenhouse gas emissions. Climate change driven by anthropogenic greenhouse gas emissions require sustainable carbon sequestration strategies. Date palms adapted to extreme aridity and poor soils and oasis soils plays a crucial role in carbon sequestration. So the last point was about the 4-Permit initiative, which have been launched with an aspiration to increase global soil organic matter stocks by 4 per thousand per year as a compensation for the global emission of greenhouse gases by anthropogenic soils. Thank you for your attention. And sorry. Thank you.
Thank you, Dr. Percy. In fact, this topic is very timely and highly relevant, especially in the highlight of global challenges related to climate change, sustainability, food security, and the carbon certificates. Thank you for your presentation. And for the audience, all the presentations will be published in the conference proceeding. So it will be published to all. If you don't have any comment, we can open the, okay, so the floor is open for two questions, two fast questions. Okay, please, Dr. Hisham.
Thank you, Doctor, for your very nice presentation. My question, I notice you make a comparison between the plants and varieties for carbon sequestration. My question, what's the difference between areas, valley or desert or like this? Is it high or down or what?
Okay. Thank you. I think it is very, very important question. I have made a comparison between different kinds of forest, for instance, in various regions in the world. In tropic regions, in temperate regions, and also in arid regions. If you make the comparisons between the carbon sequestrations in these regions and with the trees which are planted in these regions, there is a huge difference. For instance, in the tropical regions, of course, because of the plants, because of the fast growing of the plant, because of the climatic conditions. I can say that the carbon sequestration in this region is at least 10 times more important than in our region, particularly for date palms. Okay?
So,
Just one question more, or I think as we are a bit early, we pass to the. Thank you, Professor Besri. Nice presentation. Okay, so we'll call Dr. Asna Arag, please. The floor is for you.
Thank you, sir. Dear colleagues, I have the pleasure to present to you this study about the nutritional, sensory, technological, and commercial quality criteria of dates from Moroccan Nejda cultivar. In this presentation, after a short introduction, I will present some characteristics of Nejda date, followed by a comparative study of Nejda date and date from the biode-resistant cultivar, and also another comparative study of Nejda date and the date from some main Moroccan cultivar, and I will conclude, give some perspectives. Clone named previously INRA 3014. INRA means National Institute of Agricultural Research in Morocco, which is now named Nejda, is a result of initial research conducted by INRA on selecting date palm clones resistant to biode disease and exhibiting good commercial date quality among population originating from natural seedlings in all Moroccan palm groves. Quantitatively, Nejda date palm was propagated to hundreds of thousands of in vitro plants and planted in various Moroccan oases. This cultivar is now among 8 biode-resistant cultivar identified in Moroccan palm groves. It is also among 12 Moroccan cultivar benefiting from specific standards of quality, and it is also among 9 Moroccan cultivar benefiting from the label, the Moroccan label distinctive sign of origin and the quality. From point of view quality criteria characterization, several dozen criteria of Nejda date, even whole fruit, pulp and the pit were studied by INRA, giving an assessment of quality of this date and demonstrating its importance among typical, specific, and high commercial value commercial Moroccan dates. The objectives of this study is the presentation of main quality criteria and of Nejda date, and also the comparison of this cultivar with the main Moroccan cultivar. I will give you first some characteristics of this Nejda date. For the color, it have a special color which is reddish ochre color. For the form, it can be oval or oblong, and also for the skin is done, and it is characterized by its more or less complete adhesion to the pulp. For the characteristic of weight and size, I will give you an important parameter, which is the pulp importance. It can reach 93%, and the main value is 86, and it has abundant pulp, which is an indicator of good commercial quality. For the physicochemical and the biochemical characteristics, I will talk about the total sugar, which can reach 85%. And it contains less quantity of sugar, sucrose. Concerning the comparative study between the Najda and the other biode-resistant cultivars, it is, as we saw in the pictures, it has the largest size, and by comparison to the other cultivar, it is also rich, as I had said, in the pulp, and it has also semi-soft consistency. For the comparison of Najda with the main Moroccan cultivar, I have here 13 cultivar. It is the parameter of importance of pulp. It is important by comparison to the other cultivars. It is lower than of Majhoul and Bonar. And for the sugar content, Najda, it is among the group of cultivar with invert sugar. And the proportion of reducing sugar to total sugar, it's very high. It can reach 94%. For the aroma compound, Najda come in the third place after Iklan, Bouskri, Ibourar, Boufogous, with the 25 compound, volatile compound, which was detected in the pulp of this cultivar. Also, the percentage of compound present simultaneously in Najda and date of other cultivar can range between 36 and 68%. Other characteristics of Najda, it contain unique cultivar which contain a compound, a ketone, named cyclopentadecadione 1-on, which it has a pleasant mint aroma. I have here a comparison study of Najda and other main Moroccan cultivar according to the presence or absence of aroma compound. Of course, we have a significant difference of all the cultivar, but we have noted some similarity, for example, between Bouskri and Iklan, and also between Black Bousthammi and Jihel, but Najda has, there is a slight similarity between Majhoul and Najda, which they were characterized by absence of terpene alcohol and rich in ketone and aliphatic alcohol. Concerning the sensory profile, which were determined by the INRA sensory panel. As I had said about the color, we have here large color of date from golden to black pomegranate, and Najda has this specific color ochre reddish. For the texture, as I had said, it is semi-soft. And for the fibrosity of the reg, the internal part surrounding the pit, it is moderately fibrous by comparison to other cultivar which can be highly fibrous. For example, for Adomo, as we saw on the picture. And also for the other cultivar, which is not fibrous like Buyotop. For the sweet test, of course, we have the dates which they are very to moderately sweet. Najda, it is among the very sweet date, and which is important characteristic for consumer, and also for we can valorize the date which not respond to the standards on other sweet products such jam or syrup. For aromatic notes, we have detected by the nasal route 10 main aromatic notes like fruity, floral, etc. And by the retronasal route, we have detected or perceived 14 main aromatic notes such as honey, caramel, fruity, etc. I have here in this table a comparison between Najda and two others Moroccan dates. For example, for dominant other, Najda is characterized by caramel, cereals, carob, licorice, and chocolate. And for the dominant flavors, we have caramel, honey, chocolate, licorice, lemon, and carob. For the conclusion, Najda date is considered among typical and the specific Moroccan date cultivars contributing to reconstitution of the national palm groves based on high quality and biodisease resistant genotype. The significant market potential of this cultivar must be valorized and promoted, and further studies are needed for a thorough assessment of this Najda date qualities and for determining also the effect of geographical origin or the effect of the terroir of production. Also, it is important to adopt an effective promotional program to enable Najda date to reach organized market at both national and international levels. At the end, I want to present my sincere thanks to all those who contributed to the compilation of research work shared with you today. And I have finished my presentation. Thank you for your attention.
Thank you very much for this presentation. I have one question. Regarding the price, where is Nejda in the, if you distinguish with Mejoul, Bouffegous, or the varieties, where is the rank of price?
Yeah, it's lower than Majhoul. It is in the same place of Bouffegous.
Thank you.
Yeah.
So we have two more questions, please.
Thank you very much. Very nice presentations and your suggestions against resistance disease of the varieties.
Yeah.
And you know that the biot is a world-known destruction disease. In the centuries ago, biot has destroyed the 12 million date palm trees in Morocco and 3 million in Algeria since the origins of the disease. And biot is not, and still the problem is the same in the Egypt, in the Iraq, Saudi Arabia, Pakistan, UAE. And your study suggested the 7 cultivar resistance. So how it possible and what are their mechanisms for the transfer technology to the scientific community and then the farming community?
Okay, thank you. I maybe I don't understand very well the question. It is The,
Only tell me the only name of the varieties. They are resistant against the biode.
the name, the other varieties, new varieties, or the. Okay.
Biode resistant cultivars.
Yeah,
Biode resistant cultivars.
yeah. We have, we have 7 with Najda. We have now. Can I answer? Okay. We have other 7 cultivar, which they are black busthammi, white busthammi, بخني, بفقوس أموسا, سير
Good,
العيالات,
good.
إكلان, إكلان also, and the 7,
Okay.
Najda, yeah, the
Okay,
8,
okay,
yeah.
okay, okay, okay. Thank you, thank you. Okay.
Thank you.
One short question.
Ah,
Okay, thank you so much. Thank you so much. I just have one question. You talk about the pulp importance
yeah,
of each variety, and
Yeah.
then you give numbers. Just I want to know what is the meaning of importance. Is
Yeah.
this a unit
yeah,
to measure or?
yeah.
Thank
Uh,
Just a comment about biodisease. Biodisease is limited to Morocco and Algeria for the time being, and maybe in Mauritania, yes?
yeah, yeah.
But we don't have, we didn't describe it or discover it yet. I hope we will never discover it in the other countries because you've been talking about Iraq, Arabia Saudi, etc. It does not exist there, in these countries. Sorry? Yeah, we do have some symptoms that are described like they call it biode-like disease, but it's not biode. Just to make it clear for you, please.
Maybe it's arrived
Still,
to Tunisia. Maybe.
There is still the question of the one, what do you mean by important?
Yeah, okay. I will respond. Thank you for your question. The importance of pulp. We have 2 parameters. We talk about importance of pulp and also pulp content. For importance of pulp, it is the ratio of pulp weight to weight of world date, and the pulp content, it is the ratio of pulp weight to peat weight. The importance, it is a percentage, and for the second without it's gram per gram, and it is a very important parameter of commercial quality. If I can adjust something to the first questions, we are working also in developing and selecting a new cultivar, which they are also resistant to biode and of high date quality. And we have now other new varieties, not instead of cultivation in the palm groves, but still in research. Thank you very much.
The time, sorry. Sorry, Dr. Chan. Thank you, Dr. Hasna. In fact, this study is very important as focuses on the improving the quality of Moroccan cultivars and positioning the dates in the international markets. Thank you. Thank you. Now it's my pleasure to invite Dr. Mohammed Sami Ibrahim. Are you ready? Yeah. Okay. So you have 12 minutes.
Assalamu alaikum. Hello, good afternoon, everyone. Chairman, let me introduce myself first. I'm Muhammad Sami. I'm a process development engineer in Valorizon. Valorizon is a research and innovation center based in Egypt. We are focusing on utilizing the unutilized bio-waste material, and of course, especially from date palm pruning residues. Today I'll be talking about palm fill. And palm fill is fibers extracted from dead palm residues as an alternative for thermal insulation. Thermal insulation usually uses hazardous material like PU, rock wool, and so on. Now, to focus on the problem, the Gulf region uses for building sector only 70% for the building sector. So 80% of this consumption goes to the operational phase, which is cooling and heating purposes. And now to understand the cost, we are spending, this is 2024 study, $283.5 million just to import thermal insulation boards, with the UAE as the largest importer, 61.5 million. So we are paying money to import pollutants and hazardous material. This is a bright side. We have 100 million to 150 million palm trees in all over the world, and this is worth of 2.8 million tons of palm residues every year, and in other studies it's 3 to 5 million tons of residues every year. And unfortunately, we are throwing them away by landfilling or maybe burning. So now you can understand the paradox we are up against. We are throwing value and paying money to hazardous material. This is our solution. Let me introduce you to palm fill insulation mat. Palm fill is a fibers extracted from date palm residues. We extract the fibers, we separate it from the lignin, and then do refining operations and processes to reach a flexible grade of fibers that can be used in thermal insulation. So the raw material is available everywhere at near zero cost. It's sustainable, it's from natural source, and of course it will cut the risks of the logistics and make it easier. Now to the performance. For thermal insulation, there is an index or a coefficient. It's thermal insulation coefficient, and it's a unique number for each material that expresses how much heat it can transfer from one side to the other. For palm fill, it's 0.048. For instance, just to get a better understanding, for aluminum, it's 205, which is very high. Also, for the noise reduction coefficient, it's 0.7. This is also a unique number for each material, and it's for glass 0.2. Now to link the problem with the solution, it's also would be helpful to know that the solution is very near, close to us. United Arab Emirates itself has 40 million trees. KSA have 28.5 million trees. So we have the solution among our hands. About the processing of the insulation mat, after extracting the fibers, the scale is 100% industrial scale. So we can extract the fibers and then go to a turnkey solution. It's existing and no R&D work is needed for it. Of course, this corresponds to the Sustainable Development Goals, SDG 7 for clean energy, 11 for sustainable cities, 12 for responsible production, and 13 for climate action. About the circular sustainability of the product. You know, all the products nowadays wants to get a touch of sustainability, but this is a real thing. We use the soil to grow the plant. We then do the harvesting and get the pruning residues. We do the processing and we use the final product. And after disposal, it goes back to the soil. So it's 100% biodegradable. Thank you for listening.
Thank you, Mr. Muhammad. And really, it's a good work. This study is very important as it transfers data palm byproduct, dead palm byproduct, into sustainable insulation, supporting, of course, the circular economy and decarbonization. Thank you very much. And now the floor is open for any questions. Again? Okay.
Okay, so this is edible fiber, so human can eat or something like that, or just industrial based fiber. Edible fiber like dietary fiber from vegetables, something like that. So this is this kind of fiber you extract, or this kind. So it can be used for fortification of food-based item, like.
This is pure cellulosic fibers. It's for industrial uses. There are some researchers, or maybe there is a factory in Jordan is using some of these fibers to feed the animals. Yes. No. Yes. Yes. Thermal insulation.
Okay, shukran. Thank you, Dr. Muhammad.
Yes, so we'll call Dr. Malak Mohamed, please. You have the floor. 12 minutes as usual. Thank you. Can you present you shortly, please?
I'll try my best. All right, good afternoon, everyone. Thank you for joining my presentation. I'm Malak. I'm from Khalifa University, Department of Chemical and Petroleum Engineering, working in the Food Security and Technology Center. And today I'll be presenting our work on mechanochemical processing of date palm biomass and understanding the behavior of the material that we extract, particularly cellulose. So as we know, more than 60% of date palm trees are located in Middle East and North Africa. However, like particularly speaking about the United Arab Emirates, millions of tons of date waste is generated every year, including agricultural cuts, like date fronts, as well as date pits and date pomace. Despite these biomass are rich in cellulose that we can valorize, unfortunately they end up in landfill and they're wasted. So instead of wasting them, we'll just consider them as byproduct that we can valorize and extract cellulose nanofibers from them. Okay, so before we dig deeper, what is cellulose? Cellulose is the most abundant natural polymer on Earth, and it is generated at a rate of 40 gigatons per year in the world. And actually, it's one of the components of the cell that gives the cell its structural rigidity and strength. So as you see in the, on the structure of cellulose, it's formed from a repeated glucose unit that is linked by glycosidic bonds to form a long chain of polysaccharide. At nanoscale, we call it cellulose nanofibril, and each chain is connected with other chains using bihydrogen bond, forming a bigger fibers at microscale. We call it microfibers. Okay. So, how do we usually extract cellulose nanofibers? We have two steps: pre-treatment and extraction or defibrillation process. So cellulose does not exist alone in the plant cell. It's glued together with hemicellulose and lignin. So the first step, we need to remove lignin and hemicellulose using pre-treatment. And then we get cellulose fibers at microscale. So in order to break it down to a nanoscale, we use mechanical processing, like ball milling and high pressure homogenization. But, oh, sorry. But the question is, why do we need cellulose at nanoscale? So nanocellulose preserve its bulk properties like biodegradability, non-toxicity, and biocompatibility. But also at nanoscale, they gain properties like high surface area, high mechanical strength, as well as high water holding capacity. And this allows us to use it in different applications. So we can use them because they're non-toxic. We can use them in food packaging and cosmetics. So for example, here they use it as spray coating to extend the shelf life of carrot and banana. Also, we can use them to stabilize emulsions, so we can use them in cosmetics, sunscreen, and moisturizers. Also, we can use them in soil amendments to improve the properties of soil. We can use them also as 3D printing ink to print scaffolds and use them in sensing devices. So focusing on our biomass here, which is data fronts, we noticed that around 40% of data front is cellulose. So this is a good amount that we can benefit from, as you see this, in the structure of data front. And this moves us to the objective of our study, that we want to valorize data front by extracting cellulose nanofibers that we can use them later in different applications, and study the influence of different treatment steps on the behavior of our material. So this takes us to the methodology of our work. We use different pre-treatment steps, like, for example, alkali treatment using sodium hydroxide. And another pathway, we used peracetic acid for 6 hours. So we end up with alkali and oxidative. And then we combine these two processes, ending up with alkali oxidative date from cellulose nanofibers. Another pathway that we also used sulfite. So we combined alkaline plus sulfite to get this hydrogel. And we also combined another agent. And finally, we extended the severity by adding a tempo oxidation step to our process. So we get like a very harsh treatment step. And of course, after this, we get the fibers. We apply mechanical processing. Here we used ball milling for 1 hour. We characterized our material using scanning electron microscopy and X-ray diffraction. Now moving to the results. To test the stability and the behavior of our hydrogels in water, we did gelation, or we measured the gelling point of our material using tube inversion test. And we got the lowest gelling point for oxidative and alkaline oxidative data front, meaning that they form a 3D network of fibers that are stable in water. For sedimentation test, we left our fibers, the 6 samples, to sediment for 24 hours. And we noticed again that our results are in agreement with the gelation mainly for alkaline and alkaline oxidative, and alkaline oxidative, they're stable for the 24 hours. For the XRD, all samples preserve the cellulose native structure, but we notice as we go harsher with the treatment, our cellulose start to fragment, so the crystallinity decreases. And finally, here SEM images of our fibers to check their morphology. And we noticed that if we apply limited delignification, lignin will still not completely remove from fibers, so still we will have like bundles, and that's why they settled immediately. Whereas if we apply like excessive treatment, like this one, the fibers start to fragment. And that's why we have a balance by applying alkaline and alkaline oxidative treatment. So in conclusion, we can tell that date pomace, date front is a good source to extract cellulose. And by tuning the chemistry, we can tune the properties of our material. You can access full study. We published work on this, and that's it. Thank you for your attention.
Thank you, Dr. Malak. In fact, this study enables advanced use of date palm biomass through nanotechnology, and of course, adding high-value industrial applications. Thank you for your work. Now the floor is open for one or two questions. Okay, Dr. Okay, so any questions? Okay. I have a question. Yes, please.
Thanks so much for your wonderful presentation. I just have one inquiry about the XRD result. The meaningful of those XRD results and the difference, because actually I have observed it little bit difference. Can you explain more? Thank you so much.
Thank you for your question. So mainly for the XRD, we want to check the crystallinity and the structure of our fibers and to ensure that we really got cellulose nanofibers or not. So mainly we have the two characteristic peaks of cellulose that we got them, and then meaning that we preserve the native cellulose. Plus, we want to compare the crystallinity. If mainly we're studying the effect of different treatment severity. So if we increase the severity, will this affect the structure of cellulose or not? So we noticed as we increase the severity up to the one that include tempo, the crystallinity has decreased.
So you already calculated the crystallinity
Yeah,
index.
it's
you
all
already
in
have
the,
some values for sure.
Yeah, you can access it in the study. I can share it with you.
Yes,
it's also
please.
in the link.
Yes, thanks so much. Thanks so much.
Thank you.
Okay, thank you again, Dr. Hala. Dr. Malak.
And we'll call Dr. Ala Mohamed. Yeah, Dr. Ala Mohamed, excuse me. And can you present you shortly before starting, okay? And okay, in 12 minutes. Thank you.
ايوه ايوه اوكي ماشي economic and sustainable utilization of discarded date fruits in date palm from silage production. هالة محمد أنور أستاذ دكتور ورئيس قسم المنتجات الغير ثمرية بالمعمل المركزي للنخيل. صوت واضح؟ تعتبر مصر من أكبر بلاد العالم في إنتاج النخيل. يعني مصر لوحدها بتنتج تقريبا الخمس بتاع إنتاج العالم وربع الإنتاج العربي من النخيل. طبعا مع الإنتاج الوفير دوت بيبقى فيه كمية مهولة من المخلفات. من أهم المخلفات اللي هو البلح الفرز اللي هو موجود، ومخلفات البلح الفرز بتبقى كمية مهولة. هو أولا بيحصل في النخيل بيبقى فيه، يعني أنا بس عشان يبقى عندكم تصور للكمية، حوالي مثلا 20% بيبقى مع الشيص وفي مرحلة ما قبل النضج
وساعة الحصاد بيبقى في فقد لمجموعة من الثمار بيبقى حوالي 30% من الإنتاج. يعني لو قلنا إن مصر عندها حوالي 1.9 مليون طن بينتج، يبقى معناه إن مثلا حوالي 3 مليون طن أو الفرق ده هيبقى مخلفات ثمار. كمان مع الديسكاردد فروتس والديد بالم فرانس، السعف بيبقى بتتقلم طبعا سنويا انتاج النخله الواحده من الفرانس او السعف بيبقى حوالي من 12.5 ل 20 كيلو وزن جاف. لما ده يتاخد من كل مثلا النخيل، ومصر فيها دلوقتي حوالي اكتر من 20 مليون نخله، فيبقى كميه مهوله من السعف. بالاضافه الى ان احنا بنعاني في جمهوريه مصر العربيه يعني من عجز في منظومه الانتاج الحيواني. يعني اللي بيحصل ان احنا بيبقى عندنا مشكله في العليقه، خصوصا في الصيف ما بيبقاش فيه اللي هو اعلاف خضراء. فقصه ان احنا نعمل السيلاج او عمليه السيلاج بتبقى مخرج ان احنا نلاقي عليقه كويسه في بسعر كده. دلوقتي انا يعني ما خرجتش بره المزرعه، يعني احنا عندنا انتاج وفير من النخيل. انا كل الفكره اني انا هاحفظ السعف، وبدل ما استخدم الملاس على اساس ان انا اعمل سيلاج، لان هو ده اللي هو المكون اللي احنا دايما بنستخدمه في تصنيع السيلاج. بدل ما اجيب ملاس باستيراد او مش متوفر، فانا باخد اللي هي المتبقيات بتاعه المزرعه وبضيفها للسعف مع وجود اليوريا. ثواني كده، بضيف ثانية. الهدف من البحث هو ان احنا بنحاول ان احنا نعمل تقدير لاستخدام البلح الفرز مع كبديل اقتصادي للملاس. والهدف من ده ان احنا بندعم حكايه ان احنا نخفض التكلفه، وان احنا ندعم عمليه الاقتصاد الدائري او الريسايكلينج، ونحسن الكواليتي بتاع السيلاج الناتج، لان عمليه استخدام البلح الفرز بيضيف احسن من السيلاج كمكونات، وبيبقى بيحسن خواص السيلاج الناتج. وبنعمل عمليه الفرمنتيشن، بنعمل خواص التخمير بتبقى خواص افضل، وبنحصل على طاقه كليه في الانتاج اكبر. التجربه كانت عباره عن ان احنا بنعمل اللي هو الكنترول، عباره عن ان احنا بنضيف اللي هو المكون المعتاد في عمليه الانتاج اللي هو الملاس، وبعد كده المعامله الثانيه بنحط 30% ديسكاردد ديت بالم ديت فروتس، و40% في المعامله اللي هي الثالثه، مع اضافه 1% يوريا لكل المعاملات. وبعدين بنعمل عمليه التخمر بتبقى حوالي 60 يوم. بعد كده الحاجات اللي بنقدرها اللي هي البي اتش والاحماض العضويه اللي هي الناتجه كانواع تايبس يعني، والبروتين والقيم بتاعه الطاقه. الموضوع التخطيطي بيبقى ان هو الرو ماتيريالز بنعمل لها عمليه ميكس مع اللي هو البلح الفرز وبقيه المكونات مع الفرونز او السعف، بنعمل لهم ميكس، وبعدين بنعمل عمليه التخمير، وبعد كده نبتدي نعمل التحليلات. يعني نقول بريفلي يعني ان هو ما كانش فيه في النتائج فروق معنويه كبيره بين المعاملات في الدراي ماتر والبروتين الخام الكرود بروتين، لكن حصل زياده في الدهون وفي المينرالز، وده لما استخدمنا البلح الفرز حصل زياده في المينرالز والفات، وحصل تحسن في خواص ان حصل هضم للجنين اكبر، وكان افضل من استخدام الملاس. اوكي ماشي. بعد كده يقدر ان احنا نقول انه كان الاستخدام البلح الفرز كان افضل من الملاس في الحاجات دي. بالنسبه للبي اتش، كانت درجه البي اتش كانت مثاليه جدا، كانت بتتراوح من 4 ويعني و15% لحد 4.3. بالنسبه للملاس، كان انتاج حمض اللاكتيك كان هو الغالب على السيلاج بعد التكوين، يعني كان هو الحامض العضوي الاكثر تواجد. في حال ان هو كمان يعني في ناحيه اللي هي استخدام البلح الفرز، كان الاسيتيك اسيد والبروبيونيك اسيد كانوا هما الاكثر وجود يعني في السيلاج الناتج. الامونيا ليفل كانت في الحدود الامنه بتاعتها. ده شكل بيوضح اللي هو البي اتش. كانت المعاملة بتاعة الملاس تقريبا 4.1 أو 4.15. كان أفضل حاجة اللي هو الاس 2 أو المعاملة اللي هي كانت 30% من البلح الفرز، كانت 4.3. وانخفض شوية أو عند الاس 3 كان اللي هو كنت مستخدمة بلح فرز 40%. بالنسبة للطاقة، كان فعلا معدلات الطاقة الناتجة من استخدام البلح الفرز كبديل للملاس كانت أكبر في المعاملتين، وكانت أقل في الملاس. زي ما هو واضح، كانت اللي هي الطاقة الكلية تقريبا ما كانش فيه فروق كبيرة يعني، بس كان في تميز أكتر في الاس 2. يعني انه الريبليسمنت بتاع البلح الفرز مع الملاس كان افكتيف، ومن غير ما يحصل نقصان في الطاقه، سواء طاقه التمثيل او الطاقه الكليه. الخلاصه من كده ان احنا هنقول ان احنا خفضنا التكلفه، وعملنا منتج الكواليتي بتاعته عاليه، ودعمنا منظومه اللي هو الاقتصاد الدائري، وعملنا يعني تخلصنا من المخلفات ملهاش أي سعر، وحلينا بيها مشكلة دعمنا منظومة الإنتاج الحيواني. شكرا.
بالذات طبعا اللي هو الاستفاده بتحويل التمور الفارزه الى استخدامها في العلف، بما يعزم طبعا القيمه المضافه. يعني كان عندي سؤال بعد اذن حضرتك. يعني هل تم دراسه تاثير السلاج اللي هو بالتمر بدل الملاس على الحيوان في الانتاجيه في اللحوم والالبان؟
يعني لدرجه ان احنا عاملين بروجكت كده من المعمل داخل فيه، وعاملينه في الواحات البحريه، وبنعمل انتاج للحاجات دي. يعني خدنا بروجكت من أكاديمية البحث العلمي، وشغالين على الموضوع ده على أساس إنه يبقى إحنا بنحاول يبقى الموضوع سلوك، ما هواش يعني بنخدم الاقتصاد، لأن هو فعلا إحنا عندنا مشكلة، وخصوصا في الواحات البحرية يعني في حاجات أصناف ضاعت عشان كانوا بيحرقوا المخلفات، وهم الناس هناك في الواحات متحمسين للموضوع، يعني عايزين الإنتاج يعني يحصل، عشان هم عندهم أزمة علف حقيقية يعني. ماشي.
شكرا جزيلا. هل في اي اسئله؟ دكتور هشام اتفضل.
اتفضل. ايوه دكتور هشام.
شكرا دكتور هلا على العرض القيم جدا، اللي بيدي قيمه مضافه لكل اعاده استخدام المخلفات، ويدي قيمه مضافه، وبالذات زي ما حضرتك قلت في المزرعه نفسها تقدري تستفادي بدون اي كوست اضافي. السؤال: هل التمور اللي استخدمت كاضافه خارجيه، هل استخدمتي التمور السقاط في مرحله الخلال، ولا في المراحل المختلفه بتاعه التتمير، لان بتختلف، لان طبعا في مواد فينوليه وهكذا، فهل هتاثر على البي اتش ولا لا؟
دلوقتي بيحصل فقدان في المراحل ما قبل النضج. لو استخدمت البلح في الوقت ده ممكن بيحصل مشاكل للحيوانات، لان في تنين زعالي وفي مواد تانية ممكن تأثر على الحيوان سلبا. فاحنا ممكن ندخلها في اي عملية تصنيعية تانية، يعني كومبوت، ممكن مخلل، ممكن حاجات كتير. لكن بالنسبة للي بتبقى فعالة معانا هنا، اللي هي المخلفات بتاعة الحصاد، اللي هي ناتج سقط المزرعة، اللي هي مخلفات المصانع، الفرز التاني، دي هي اللي لان بيبقى كمان نسبة السكر فيها عالية. وهو جوهر عملية السيلجة هنا انه يبقى في كمية سكر كبيرة. كمية السكر هي اللي بتعمل التخمر، فهي دي اللي بتنجح العملية. متشكرة جدا، متشكرة جدا دكتور انك انت، لان انا فعلا كنت عايزة اقول النقطة دي. ماشي.
شكرا جزيلا.
شكرا ليك. انا طبعا سعيدة جدا بوجودي وسطيكم، ويعني ده شرف كبير ليا يعني. Thank you very much.
Okay, we'll call now Dr. Rabi Mohamed, please. Floor is for you.
Yes, present yourself.
السلام عليكم. بالنسبة للمحاضرة التي سوف ألقيها إن شاء الله ستكون حول التأثير المشترك للتلوث المعدني والجفاف على تنوع ووفرة الفطريات الجذرية في تربة بساتين نخيل التمر المتضرر.
قدم نفسك وبيئة العمل.
أنا راضي محمد من المغرب، أعمل في المختبر البيولوجي حول نخيل التمر. كما تعلمون في مراكش كانت the air of Palmyra كانت مساحة الواحات النخيل في سنة 1898 بلغت حوالي 15,000 هكتار، وانخفضت هذه المساحة سنة 1990 إلى 8,000 هكتار، وذلك نتيجة للزحف العمراني والجفاف وفقر التربة من الذبال والعناصر المعدنية. إذن ويؤدي نقص الصيانة والعناية الجيدة للتربة إلى عدة مشاكل في التدهور، مما يستوجب إجراء دراسة أكثر تفصيلا لفحص تأثير العوامل المؤثرة على واحة نخيل مراكش. إذن فالتلوث pollution المتمثل في المعادن الثقيلة والأنشطة البشرية، زائد الجفاف المتمثل في ندرة الأمطار وارتفاع درجة الحرارة وانخفاض مستويات المياه الجوفية، يؤدي إلى انخفاض وفرة المجتمعات الفطرية، مما قد يسبب في انخفاض نمو وتطور النباتات نخيل التمر. إذن بالنسبة للفطريات شامبينيون، بالنسبة للفطريات فقد تتواجد في جذور النخيل التمر على شكل علاقة تكافل، بمعنى أنها تشكل شبكة حول جذور النخيل، وهذه الفطريات تساعد أو تكبر توسع من مساحة الامتصاص الأملاح المعدنية والماء، وبالتالي فهذه الفطريات تنقل الأملاح المعدنية والماء نحو جذور النخلة، مما يساعد في نمو النخلة. في المقابل فالنخلة تعطي للفطريات السكريات، تزودها بالسكريات والأحماض الأمينية. إذن هناك تبادل منفعة أو تكافل. C'est des changements entre les mycorhizes et les racines de... C'est la symbiose. Oui, oui. لهذه الدراسة اخترنا ثمانية محطات. On a choisi 8 stations. محطتين محيطة بالمدن يعني بيغي إربان انفيرونمنت، وست محطات حضرية إربان انفيرونمنت، يعني 3 حدائق و3 شوارع، بحيث أن الشوارع تتميز، يعني النخيل الموجود في الشوارع يتميز بأشجار النخيل في بنيتها الطبيعية، ولكن لا توجد أنشطة زراعية، لا تواجد مجموعة متنوعة من الأنشطة البشرية، حركة المرور على الطرق، التخلص من النفايات، يعني تلقى نخيل تمر موجود في الشوارع تريبولي ملوث. إذا بالنسبة للماتريال اند ميثود، أخذنا من كل محطة اخترنا 15 نخلة، وفي كل نخلة حفرنا 40 سنتيمتر كما مبين هو في الصورة، وأخذنا الجذور مع التربة، يعني الجذور تكون مصحوبة، جذور تكون فيها الفطريات، وفي التربة فيها الأبواغ السبور. وأخذنا التربة وملأنا بها أكياس، أكياس بلاستيكية حوالي كيلوغرام، ومن بعد قمنا بعملية الزرع، بذور التمر، وعرضناها للإجهاد المائي لمدة 8 أشهر، يعني الإجهاد المائي يعني لنعرف مدى تأثير الجفاف حول، يعني تأثير الجفاف حول النخل. إذا عملنا على 25% من الإجهاد المائي، 50%، 75 و100%. On a fait ici le stress hydrique. إذا قمنا أيضا بتحديد الخصائص الفيزيائية والكيميائية للتربة determination of soil physicochemical characterization. ثم أيضا قمنا بتحديد المعادن الثقيلة heavy metal determination باستعمال تقنية speciation. On a fait la technique de spéciation pour déterminer les métaux lourds existent dans le sol. إذن كما تعلمون في التربة توجد المعادن الثقيلة على عدة أشكال. على سبيل المثال إذا أخذنا مثلا الرصاص ليد، هذا الرصاص قد يوجد في التربة على عدة أشكال متنوعة. الهدف من هذه التجربة هو أن نبين ما هو الشكل الذي يسبب في قتل أو في تسمم الفطريات الجذرية، لأن قد يكون مثلا نجد الرصاص يوجد على عدة أشكال، شكل إشانجابل فراكسيون، سوليبل فورم يعني الشكل المذاب في الماء يعني على شكل أيونات، شكل أورجانيك فورم يعني مرتبط بالأملاح العضوية، بالمعادن العضوية، بالأملاح، نعم معدنيه لا بالماده العضويه، مرتبط بالماده العضويه، فورم اورجانيك، فورم كربونات يعني مرتبط بالكربونات، ويوجد فورم سيلفيد يعني مرتبط بالسيلفيد، وهناك فورم ريزيديال. كي نحصل على هذه الاشكال نقوم باضافه عده محاليل هي مذكوره هنا واحدا تلو الاخر، وكل محلول يعطينا شكل معين، وكل هذا من أجل أن نحدد من هو الشكل الذي يسبب في تسمم وفي قتل أو في حد الفطريات. ثم انتقلنا إلى كشف كثافة استعمار القشرة أو intensity of cortical colonization، يعني أن نحدد الفطريات الموجودة في الأغصان في جذور النباتات. وحددنا أيضا السبور يعني الأبواغ الموجودة في التربة بالنسبة لكل محطة. هذا النتائج. بالنسبة للنتائج فيزيكوشيميكال الأملاح، نلاحظ أن الأملاح المعدنية هنا المكتوبة باللون الأحمر توجد بكثرة في الشوارع، في محطات الشوارع بولفار، على عكس البساتين والحدائق. يعني بالنسبة هنا نحدد على أشكال الأشكال التي هي تسبب التسمم أو قتل الفطريات هنا في الشوارع كما تلاحظون. هنا بالنسبة للشوارع توجد في الشوارع فقط وشيء قليل في الحدائق، ولكن هنا الشكل هو مثل اختطال، يعني الشكل بالعربية الشكل العام مثل اختطال بلا تخسر. ثم هناك شكل آخر هو H2O، الشكل مذاب في الماء، ثم فراكسيون اشونجابل. هاد الاشكال فراكسيون اشونجابل والسوليبل فراكيشن، وهذا الشكل مثل الاختطال هم الذين نجد اكثر في الشوارع، هم الذين يسببون لهم تاثير مباشر على الفطريات عكس الاشكال الاخرى. بالنسبه لتاثير الاجهاد المائي ستريس هيدريك، نلاحظ ان الابواغ، كثافه الابواغ هنا السبور منتشره جدا وتوجد بكثره في الحدائق وفي البساتين، على عكس الشوارع توجد بقله. اذا فنلاحظ هنا بان هناك تأثير مباشر لهذه الأملاح المعدنية، لهذه المعادن الثقيلة الموجودة في الشوارع على كثافة الأبواغ. يعني كلما ارتفعت نسبة الأملاح، نسبة المعادن الثقيلة، إلا وانخفضت نسبة الأبواغ. نلاحظ هنا الفطريات، صور ديال الفطريات الموجودة في جذور النخيل. هنا ننطلق إلى معايير النمو بالنسبة لتأثير الإجهاض المائي. نلاحظ هنا الإجهاض المائي 100% و75% أن النباتات تنمو بشكل جيد، على عكس 25 و50%. نفس الملاحظة بالنسبة لمساحات الورقة وطول الجزء الأخضر والعدد الأوراق. بالنسبة للحدائق والبساتين النباتات تنمو بشكل أكثر وبشكل جيد، على عكس الشوارع. إذا ننتقل الآن إلى العلاقة الموجودة بين الجفاف أو بين الإجهاض المائي ثم بين التلوث، وهل له تأثير مباشر إذا اجتمع على نمو النبتة. بالنسبة ل 25% يعني تحت الإجهاض المائي يعني كاين الجفاف، ماذا نلاحظ؟ نلاحظ هنا أن الاملاح المعادن الثقيله البلوم الكويفر اند الزنك مجتمعه في نفس المكان الذي تجتمع فيه الشوارع، توجد فيه الشوارع. يعني ان التركيز ديال الاملاح المعدنيه توجد بكثره في الشوارع، على عكس الحدائق والبساتين. كما نلاحظ هنا ماذا يتوزن؟ نلاحظ هنا معايير النمو، طول النبتة والى اخره. بعض المعايير هي التي توجد في الجهة التي توجد فيها البساتين. يعني هناك علاقة بين تركيز المعادن الثقيلة على النباتات. هنا فين كاين الشوارع لا يوجد فيه نمو، النمو قليل جدا، لا يوجد. نفس الملاحظة بالنسبة هنا مع المو في الشوارع. توجد هنا الشوارع نلاحظ ارتفاع التركيز ديال المعادن الثقيله عكس البساتين. نفس الملاحظه بالنسبه للايجاد المائي 75 و100%. إذا
لديك دقيقة conclusion.
إذا في واحة نخيل مراكش تؤثر العوامل التدهور، الجفاف، ملوحة التربة، التلوث العضوي والغير العضوي تأثيرا مباشرا على التنوع البيولوجي للفطريات المرتبطة بنخيل التمر، ولا سيما كثافة الأبواق لهذه الفطريات التي تتناقص تدريجيا مع ارتفاع درجة النشاط البشري. كما تشهد هذه المنطقة تدهورا مستمرا خاصة على طول الطرق الرئيسية بسبب ارتفاع مستويات المعادن الثقيلة في التربة، وهو ما قد يكون مرتبطا بارتفاع معدلات موت أشجار النخيل. وشكرا.
بحث عن تأثير التلوث والإجهاد المائي على صحة التربة والنخيل نفسه. المجال مفتوح لأي أسئلة. The floor is open for one or two questions. Okay, please.
شكرا أستاذ راضي على أنا أسأل يعني الميكرويز، معروف أن الميكرويز يعني بتأثر على انتشار الجذور، بتعمق الجذور، وبالتالي فأنت بتدرس تأثير الإجهاد. وهل يعني أولا هل حددت نسبة الميكرويز في الواحات أو في منطقة الدراسة في النخيل في واحة مثلا مراكش، كم نسبة الميكرويزم الموجودة في الجذور؟ الحاجة الثانية تأثيرها على الإجهاد البيئي. الإجهاد البيئي معروف أن الميكرويز بتقاوم من أهم الصفات التي بتأثر الميكرويز على النباتات، أنها تعمل على مقاومة الجفاف النباتات، وذلك بتوغل الجذور.
سؤال في محله. نعلم بأن الميكوريز كلما ارتفع الجفاف إلا وارتفعت نسبة الميكوريز، لأنها كنوع من أنواع المقاومة التي تعملها النبتة لمقاومة الجفاف. وهذا هو اصل ديال البحث ديالنا. البحث هو دراسه تاثير اولا الجفاف، لان الجفاف سيقوي من الميكوريز، ولكن تاثير التلوث المعدني على الفطري. هذا هو الهدف ديال الدراسه، فهمتني؟ اذا التلوث يهدم او يقتل الفطريات الموجوده، خصوصا الابواق يقتلها. إذا فقدنا ولا إذا نقصت كمية الفطريات أو كمية الأبواق، يؤثر هذا بشكل سلبي على نمو النبتة. نعم وجدت. نعم 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 توجد علاقة وطيدة.
Any more questions? Okay, thank you very much, Dr. Radi. Thank you for your presentation.
Thank you.
Yes, excuse me. So, Dr. Wissal Isami, please, floor is for you. Just you present you shortly.
دكتورة وصال، عرفي نفسك الأول للأودينس.
Good morning. My name is Wissal Isami. I am postdoctoral researcher in Date Technical Center, and it's honor to participate in the 8th International Date Palm Conference. I will present my work today about compost and about compost. Oasis agriculture generates large amounts of date palm residues. Dried fronds are rich in lignin and cellulose. These materials decompose very slowly in the nature. In many cases, residues are burned or left in the field. So composting represents a sustainable waste management solution. The objective of this work is to characterize compost derived from oasis waste and to monitor physico-chemical parameters, temperature, pH, and electrical conductivity, to analyze chemical composition using HPLC and GCMS, and to evaluate its potential for agronomic application. We use it in this work date palm fronds and household organic waste. The mixture was 70% fronds and 30% organic waste, and the moisture content is 55%. Composting process. Composting was conducted under windrow conditions in 35 days, performed on an aerated concrete platform. Moisture was maintained at 55%. Physico-chemical monitoring and chemical analysis. Temperature measured daily at different depths. pH and electrical conductivity measured in aqueous extracts. Analysis performance. HPLC, we used in this work HPLC and GCMS. HPLC for to analyze the phenolic compounds, and GCMS for to analyze volatile organic compounds. Temperature evolution during composting. Temperature increased rapidly during in the initial phase. La première phase, c'est la phase mésophile du compost. The thermophilic phase reached 55 to 60 degrees Celsius. This indicates intense microbial activity. Then temperature gradually decreased toward ambient temperature. Finally, compost reached stabilization phase. pH and electrical conductivity evolution. pH increased from slightly acidic to neutral alkaline. This indicates degradation of organic acids during composting. Electrical conductivity remained moderate. This means no excessive accumulation of soluble salts. Therefore, the compost is suitable for horticulture. Chemical characterization. HPLC revealed moderate levels of phenolic compounds. This indicates transformation of linocellulosic materials. GCMS showed low levels of volatile compounds like alcohol, ethanol, mainly alcohols and organic acids, so no compounds related to anaerobic degradation. This table summarizes the chemical characterization results. Moderate phenolic compounds indicate linocellulosic transformation, like ferulic acid, p-comuric acid. Low volatile compounds reflect normal decomposition, so no anaerobic compounds were detected, confirming a fully aerobic process. In discussion, efficient biodegradation of linocellulosic materials. The composting process followed a typical thermophilic phase, followed by stabilization. pH and electrical conductivity indicate compost maturity, so no toxic compounds accumulated and aerobic conditions were maintained. These results confirm the production of a stable and mature compost. In conclusion, compost derived from oasis waste showed stable physico-chemical properties. A favorable chemical profile was confirmed by HPLC and GCMS. No evidence of anaerobic degradation observed. Suitable for agronomic application. So, a promising solution for a sustainable waste management in oasis systems. Thank you for your kind attention. My English is not well. Je parle français. Okay.
Thank you very much, Dr. Osal. The floor is open now for any questions.
just one short question. Did you try, because you are obliged to cut the leaves in small pieces?
Pardon?
Can you imagine a system where you don't have to pass by this first phase? Je vous le dis en français ou you understand in English, no?
Can you repeat, please? I don't.
Can you imagine a system of compostage, not cutting the leaves in small pieces, but using them without any mechanical treatment before?
Can you speak French, please? I don't. My English is not very well. I don't understand.
Est-ce qu'on est obligé de passer par cette phase de réduire les palmes en petits morceaux, ou est-ce qu'on peut imaginer un système où
Le
les
palme sèche, tu parles de
sèches,
palme sèche, oui.
ou est-ce qu'on peut imaginer un système où on garderait les palmes entières?
Oui, il y a des travaux de recherche qui.
English.
English, Oui, il y a.
Allô?
Est-ce que je peux en
Bonjour.
français expliquer en français?
Morning.
Il y a des composts, il y a des travaux de recherche qui concernent le compost. Ils ont fait ils ont laissé les palmes toutes entières, mais ça dure plus longtemps que broyer les palmes sèches pour l'utiliser dans le compost.
Okay, merci. Thank you very much.
Thank
Any
you.
more questions? Okay.
English.
Okay. Thank you very much, Dr. Usal. Thank you.
Thank you.
Yeah. It's Dr. Sabira Harris.
Yes, can you introduce you shortly? And we have 12 minutes. Okay, thank you.
Assalamu alaikum and good afternoon, everyone. I am Dr. Sabira Harris. I'm an assistant professor at Abu Dhabi University. The work I'm going to present today is done in collaboration with Abu Dhabi, UAE University as well as KU Leuven in Belgium. So the title of my talk is Evaluating the Environmental and Economic Viability of an Integrated Biorefinery for L-lactic acid production from date fruit pomace. So as you all are aware that, today, something that is silently and steadily infiltrating our environment is the plastic pollution. We cannot live without plastic. It has become an indispensable part of our life now. So one of the solutions, to address the plastic pollution is to replace the petroleum-based polymers with biopolymers. So as per the statistics, global bioplastic production capacity is estimated to reach 6.3 million tons by 2027. Also in the market, there are various types of biodegradable polymers available. Okay, like you see in this figure, you have, degradable cellulose, bio-PET, and so on. But there is one particular polymer, which is called as PLA, or polylactic acid, that has a huge demand. Okay, we've been hearing, whatever you see in the market as biodegradable plastic is made up of polylactic acid. Okay, and it's also widely being used in biomedical applications as well as scaffolds and tentures and as joint, scaffolds and so on. So to make the polylactic acid, the monomer or the starting material is the lactic acid. So my research was focusing on how to produce lactic acid in my lab using a waste biomass. Okay. So as you all know, lactic acid is an organic acid. It has a lot of applications in food industries, pharmaceutical industries, chemical industries, cosmetics. People are using lactic acid serum on your skin, right? So there are a lot of applications. And apart from that, lactic acid is now being polymerized to polylactic acid, which is used for as a sustainable food packaging in biomedical applications and so on. And the big companies, let's say the NatureWorks or Corbion in US and the Futero in Belgium, they all produce lactic acid mainly from corn, like you see here, sugar cane, sugar beet, cassava, and so on, which you all know are food sources. So as a sustainable response to the debate that is surrounding the food versus energy nexus, we were in search of a biomass, a second generation biomass that can be used for producing lactic acid. And in this part of the world, as we know, the material or the biomass that is widely available is date palm waste. Okay, but the fermentation inhibitors, or the difficulty in using date palm waste for fermentation. We don't get enough. Yield is lower. And you see here, the lactic acid can be primarily produced in two ways, either the chemical method or the fermentation route, which is the most eco-friendly or green route because it doesn't involve a lot of energy-intensive process. And as you see here in chemical route, you always produce something called like a mix of D and L lactic acid. But I was looking particularly for L lactic acid, so fermentation route is the most beneficial route. Okay? And that was what I was following for my research. So as I said, date palm waste, the lignocellulosic material which we all have worked on, I have made sustainable packaging from date palm leaves. But you see, the yield is less, or to get the glucose content from the cellulose, you need a lot of enzymatic digestion to get the glucose, then to convert that to lactic acid. So I came across the date fruit pomace, again, which I'm sure you all are familiar with. So date fruit pomace is actually the byproduct from date processing industries. We all love date syrup to be used on ragag and lukemat. So after getting the date syrup out of the date fruit, whatever is left over as the solid residue is the date fruit pomace. So I was looking at the possibilities of using date fruit pomace as a feedstock for lactic acid production. So as I said, it's a major byproduct of the date processing industry, and it's the solid residue that is remaining after the date syrup extraction. And currently it is sold as an major ingredient in the animal field. So my first step was to see what is it made of. So, to build in a strategy or to design a, a production route, we need to know the building blocks of your biomass. So first step was to know its, characterization. So I found out that, like you see in this figure, around 45.5% of it is made up of dietary fiber. And then there is a total sugar, which is a mix of glucose and fructose, which comes up to 35.3%. And it shows that it's a sugar-rich, biomass, which shows that it's a viable feedstock for fermentation. Okay? So just to give an overview, I used the date fruit pomace using lactic acid bacteria, particularly Lactobacillus casei. That was the strain I used to produce lactic acid. But in the process, I am also generating a fermentation residue. So to minimize the waste that is produced in my process, I am also looking into two scenarios, especially when I'm building up a biorefinery, which I'll come into when I talk about it in the slide. I was looking into making two co-products from the fermentation residue that is left over after fermentation into biochar or a dietary fiber. And then I established or tried to design a biorefinery that is based upon the date fruit biomass. And I did a techno-economical study to see the economic feasibility of establishing a biorefinery in this part of the world. And along with that, I did an LCA study, that is the life cycle assessment, to see if it is a sustainable process, or how much is the environmental impact that the biorefinery could make. Okay, so these are the tasks I followed. The first one was the fermentation using the bacteria Lactobacillus casei, and I used the enzyme CTEC2, which is a cellulase enzyme. As you saw, while doing the characterization, we found out that the pomace is comprised of 45% dietary fiber, which is basically the cellulose. So if I can digest the cellulose to more glucose, then I can get higher yield of lactic acid. The second task was to perform a techno-economic analysis, and the third one was to do an LCA study. So this is what I explained. In the first task, it was the fermentation, followed by enzymatic hydrolysis to see the effect of adding an enzyme to my process. and then finally looking at the purification. So I optimized all the parameters that is required for the fermentation, including adding the various salts which is required for higher production of lactic acid. So it makes the bacteria more comfortable to produce the byproduct. And I looked at various biomass loading like 10, 20, and 30 gram per 100 ml of the fermentation broth. The temperature was kept at 38 degrees Celsius because that is the most optimum temperature for the bacterial strain that I'm using. And I also looked at the production yield on second day, third, fifth, seventh, and 10 days. And initially, the experiment was carried out in a shaking incubator. Then I scaled up to a 1 liter fermentation tank. And the lactic acid was quantitatively analyzed using an HPLC. And the column used was high-plex H column. And the sugar was quantitatively analyzed using Resex RCM monosaccharide LC column. As I said, we had a 45% of, the dietary fiber. So I saw the effect of adding the cellulase enzyme, which can convert the cellulose to more glucose. More glucose means more lactic acid in my production. And these were the parameters which I optimized with. And then finally, the lactic acid was purified using a phase partitioning method to get the pure L-lactic acid, from the fermentation broth. Okay. And then I did a techno-economical analysis. For this, I used a software called SuperPro Designer, where I can design the unit operation that is required for my process based on the methodology that I followed in the laboratory. And the OPEX and CAPEX was calculated from the software itself. And I did an LCA using the SimmerPro software, where we looked into the midpoint approach, like we were looking into the midpoint impact categories like global warming, the CO2 output, the ecotoxicity, terrestrial toxicity, marine toxicity, the water consumption, and so on. We also looked at the endpoint approach as well to see how much is the damage done to the humans or the natural resources, and so on. So coming to the results, so the first task was to do the fermentation. And my first step was to make my media appropriate for the lactic acid fermentation. So I looked into fermenting only the pomace alone. Then I had added the yeast extract, which is the nitrogen source. I also looked at two concentration of adding yeast extract. And then finally, I looked into adding the salts, which I showed you earlier in the methodology section, a mix of vitamins and salts, so it becomes more appropriate for the bacteria. And then I found out that the media, which has the yeast extract at 20% and the salts gives higher lactic acid concentration. And then I also looked at the effect of various biomass loading, various time, various inoculum loading, and so on. And I found out that at the 7th day, I'm getting the highest lactic acid yield. And here, the two graphs shows the effect of lactic acid with and without enzymes. So in the without enzymes, you can see, the pomace, as it existed, it had higher content of fructose compared to the glucose. And then as the bacteria was using it up, we were getting the lactic acid, as you see, fructose and glucose concentration coming down and building up of the lactic acid. I was getting around 207 grams of lactic acid from 1 kg of pomace. But when I added the enzyme, which is the Selec-CTEC2, which is a cellulase enzyme, what it did was it converted the cellulose in the dietary fiber to more glucose. Hence, you see it in the graph. I have a higher content of glucose now. And then the glucose and the fructose was used up by the bacteria to give a higher yield of lactic acid. And we got around 457 grams from 1 kg of the pomace. And then the lactic acid was purified using the phase partitioning method. And the L-lactic acid, it was confirmed using an NMR study to make sure it was a L lactic acid that I was not getting, not a basic mixture or a D lactic acid. So the test, so to conclude, let me go to the results section now. So we did an, designed the biorefinery, you see here, and then there were 2 scenarios, and I found out that the second scenario was much better because we had the dietary fiber, which is the co-product, which has higher value. Similarly, when I did the LCA study as well, when you see the comparison, my scenario 2 looked much better. Okay, similarly for the endpoint and the midpoint sector. So basically, I have to conclude is that the date fruit pomace is indeed one of a promising feedstock for fermentation. And with my LCA and my techno-economical study, I even established that having a biorefinery in this region could be economically feasible and technically feasible as well. So that's all from my side. Thank you so much. If you would like to connect with me, you can scan the QR code. My LinkedIn account is on there. Thank you so much for listening.
Okay. Thank you, Dr. Sabira, for your valuable work. It's really very good. And now the floor is open. If is there any questions? Okay. Have you questions? Okay, Dr. Sabira, no question. Thank you very much.
Thank you so much.
Dr. Zainab Fauzi, please. The floor is. Thank you. Can you introduce you? And you have 12 minutes. Thank you.
السلام عليكم ورحمة الله وبركاته. كيف الحال؟ معكم دكتورة زينب أحمد. I am associate professor in the Integrative Agriculture Department, College of Agriculture and Veterinary Medicine, United Arab Emirates University. So, can you hear me very well? Okay. So, okay. Today I'm going to share with you part of our research, which is a part of مبادرة التحالف العربي للبحث العلمي والابتكار. This project was in a collaboration with 10 countries, Arabic countries actually, from the east to the west. Start from Qatar, Oman, Emirates, Iraq. We have Saudi Arabia, then Egypt, Libya, Tunisia, Algeria, Morocco, and Mauritania. So all these countries have been part of this project. And today I'm going to share with you part of the results that we reached out. So if I'm going to talk about the part that we have done here in the UAE, we're going to, why it move by itself? حرق البرزنتيشن كده. كنت عايزه اعمل لكم مفاجاه دلوقتي. ثانك يو كمان خلصنا الحمد لله. ده اللي قبليه ده ثانك يو. سو لو حبينا نتكلم عن انتاج النخيل، اتكلم بالعربي ولا بالانجليزي؟ انجلش ها؟ اوكي. So if we're going to talk about the date palm production in the UAE, we have specific places where we can grow date palm, especially in the Oasis area. And UAE is known to have a biggest number of date palm trees in the world, about 44 million trees. 8 million of these trees are in a line by itself. And one of the slides I will show you that there are 3 main areas where date palm are growing, especially in the Abu Dhabi Emirate. We have Al Ain as the biggest area, then followed by Al Dafra, and then Liwa region. And here in UAE, we are making like a festival for date palm, especially in the Liwa. It's called the Liwa Festival. Okay, no problem. Uh, يعني هنا oof, it's okay. We can see here the three main part where is the date palm are produced in the UAE. Here is a line, and here Al Dhafra, and then Liwa Oasis, and these are the main area where is date palm are growing. In the UAE, we have about 120 female known cultivars and about 11 male known cultivars. Date palm is only one. Okay, so date palm is considered critical for food source and food security in the UAE, and it is part of our heritage and history. We are considered the world eighth top producer with 15,000 tons, and the fourth largest exporter. And the cultivars that produce here in the UAE is a high quality cultivars that have been found in the market. We are not only producing the fruit, but also we are adding value to the fruit. So we have different product out of the date palm that you can find in the market that adding to the value of the date fruit. Commercially, the date palm are produced artificially after the artificial pollination. So it's not an easy task for the fruit to be produced. It has to be artificially pollinated in order to get the fruit at the end of the season. Okay. Please. Sorry. بيمشي مرتين ثابتة كده يعني تك واحدة يمشي ثلاثة مش عارفة تكته أوقفه يا أمشي بإيدي يا برجلي. Now it's working? Okay. So in conclusion, much better صراحة. I can say. I know, but I want to show you some picture, good picture, and some data. So the idea of the project actually is to take care of kind of male date palm. So all the research have been done, and we can see here throughout the conference, even all are focusing on the female date palms that producing the dates. But male, um, I did not see any of the research on that. Despite 50% of the yield is relying on the male. Without pollination, you're not going to have fruit at the end. So the source of the pollen for pollinating the female date palm is very important. And we have done a survey here in the UAE and other countries to check with the farmer what is their source for the male. So from that, we find the very variability. Like each farm, almost here in the UAE, they are using their own male. And some people know the cultivars that they have. Some pollinate with it and have no idea what is the name even of it. So from the data that we collect from the survey, I found almost 11 known male cultivar, including like Ghanami, which is very common. And then one, they call it Sikka. Another one, they call it Al-Ain, like Fahl Al-Ain. So maybe these males are known, but maybe they are relative, but the farmer themselves doesn't have no idea about the name. Is it really Ghanami or is it Al-Ain? Is it what? They don't know. So from that, the source is not known. So apart from that, they actually the farmer had no idea of the source of pollen that they are using. Okay, so this different. Okay. So والله مش هدوء انا مش هلمسه اصلا خالص ده. Okay. Okay. So no matter what is the method they are using to pollinate, if they are pollinating by hand or by spraying or by water suspension, whatever the method, but the pollen source should be known, and it should be from the high quality source as well. Another question in the survey, we were asking the farmer about if they didn't have enough pollen, what they do? Did they borrow from the neighbor, or they purchase from the market, or what is the other source? Some of them said, having like a kind of borrowing from my neighbor farm or purchase from the market, and in the market they are mixing the pollen, so I'm purchasing it, and I don't know. I have no idea about the quality, but I'm using it. What to do? So the source, which is the 50% of our production relying on it, they are not a reliable source. That is really a thing that was surprising me, and I think it's happening not only in the UAE, but it's in all the Arabic countries as well. So okay. With the slide of different implementation methods. So last cycle, we have done experiment using a drone to pollinate the date palm, and this process was really efficient compared to the manual one in many different countries. I know that using a drone have been done in several countries, but using the powder of the pollen, but we are using a water suspension, and we are using a bigger drone. And with that, still, even if with a high technology in the pollination, still the source is very important. So we use the Ghanami, and with Ghanami in different cultivars, we find successful method and unsuccessful method, which means that even with the good technology or high technology, still we cannot reach the maximum production of the date palm, and this is the reason. And what is the reason is the pollen. So again, pollen maybe work with barhi, but not complementary with khisab and so on. Okay. So in our survey also we asked the farmer about that. Did you find a problem when you are pollinate the whole farm, that the pollen work successfully with all the cultivars that you have in your farm? Some of them say yes, this ghanami I have, it work with barhi, but not working with fard. It work very well with khinezi, but not with khalas. So again, the problem is here, and we should be aware of. So I searched in the UAE, and I found two companies, Al Wasba and another one, Al Fu'a. They are now having their own farm for only male, and they are targeting the market of pollen, and now they are trying to doing too much effort into, or putting too much effort into having high quality pollen, so they can sell it to the farmer and provide a good and reliable source for the farmer. Okay. But this company actually reached us as a university and asking us about a good method to store these pollens. Okay. So usually most of the farmer, what they are doing, they are using the same pollen for the same season and pollinate their trees. How about the early cultivar that female flower open early and there is no male pollen? What they are doing? So they need to have a last year pollen that have been stored for a whole year. So this company, they had problem or issue with storing these pollen for a period of a whole year. So we start to search on the right method to store these pollen. So the objective of this project that I'm going to present today is about the exploring the effective method for preserving these date palm pollen for commercial date palm production, breeding program, and long-term conservation. So for this, I tried to collect from different male source. Some of them are known, some are not known. I collected about 10 samples from different farms that the farmer have been using, and they claim that they are very good quality. They're giving them good yield, and I air dry them, and then get this pollen to start testing their viability and germination to see if they are in a good quality at the time we harvest them. Then we store them at 3 different temperature, which is the refrigerated temperature, and then -20, the freezing, and then 196, which is in liquid nitrogen, or what we call it cryopreservation. And we saved it for 0, 6, and 12 months. This is from the farm where we collected, and here where we collected the flower at the season. That was in February and the beginning of March. And we collected and brought it to our lab in order to extract the pollen. And these are my students working in the lab. So we collected the pollen and we start to measure the quality of this pollen at the time of harvest, and then after 6 months of preservation at different temperature, and then after 1 year. But so far we did not get the 1 year data, so we're gonna show you the after 6 months data. So at harvest, you can see the pollen viability percentage, as you can see here, and then the smell, the color. I can't touch it to show them. So you can see from these 10 samples that we collected, you can see the variability for the pollen viability here. Start from 53, which was the lowest, 53%, 0.8%, and then the highest was 96.8%. This pollen, also we measure the smell for it and the color, which is the method that the regular farmer used to use it as an index of the quality. So I told them how you measure the quality of the pollen and tell this is a good one. They said we smell it. If it has very strong smell, this is good. If it has a very light white color, this is good. But I can see that yellow color I have, and then white, and then strong and mid smell. And you can see that the smell and the color has no relationship with the viability. So we can see that the highest one, which is S8, the viability 96.8%, it has mid smell, not that strong smell, and has yellow color. Another one, it has a white color, it's 79.8%, which means that these are not good indicator of the quality the farmer used to say that this is high quality pollen. So after preservation for 6 months at different temperature, at the 25%, which is at room temperature, we can say, you can see the pollen viability, and then at 4, 20, and then 196. And you can see that at 4 degree, the viability have been decreased by about 50 or 40 to 50%, which means that this pollen should be used only for the same season. It cannot be stored for the whole year because it will lose the viability, or at least 50% of the viability. At minus 20, which is freezing, it is okay in the middle, but when we store it at the liquid nitrogen or cryopreservation, you can see that the viability have been preserved. So if you see that the highest one, which is S8, 96%, is still 91% after 6 months, compared to 4, which is 71%. Even the lowest one, which was 53%, at 4 have been decreased, but at 196 is still 50, which is did not lose only 3% after 6 months. So with that, we can see that the cryopreservation is the best way to maintain or keep the quality of the pollen grain, and can be better way, and we can recommend it to this company to keep the pollen grain that they harvest from the same year in order to keep it for the next year with a almost similar viability percentage compared to the time we harvest. And this is a picture of our students while they are working. Lots of them were very interested in the project and they want to share. It was actually too much work to work with the pollen extraction. Some of them got allergy because we were doing it in the lab and the smell was very strong and everybody was smelling it. So, but they were very excited and working in the project. Okay, so with that, I would like to thank you and as welcoming you in the UAE, and today is the last day, and hope you enjoy your time here, and I'll be happy to take your questions. Sorry for this.
Thank you, Dr. Zainab. I have a question, please. have you made some germination tests or fertilization
Yes,
tests?
yes.
Only, or you depended only with the appearance and color and to test
Yes.
the well?
Actually, I've done too much data and have, but I did not bring it here because it's like the limited time they said. So, but we measure lots of things in the pollen, starting from measuring the viability using the acetocarmine and the tetrazolium test, and we tested under the microscope as well. We tested germination, okay, to see also the germination percent. We also measure the characteristic of the pollen under the microscope, scanning a microscope to see if they have any defect of any like the structural surface of the pollen after the 6 months. And what else? We also measure the protein content, the mineral content of it. This all data we have actually. So
Thank you very much. The floor is open for question. I am waiting to hear Dr. Ismail, please.
فضولي ها. السلام عليكم ورحمة الله وبركاته. دكتورة زينب، من المعروف انه تنبيت لو عملت من فحل واحد تشوف في بعض الشيص بسبب عدم التوافق بعض الأحيان.
Right.
عندما تعمل أكثر من يعني كنا نخلط 4 مع بعض، نعمل البودر وكذا، لو بلش نحن 4 مع بعض ساعتها عندنا أقل من اللي عدم الإخصاب. هل هذه التجربة عملتيها؟ هل اللي كان بس واحد
عملت ميكس
كانت أقل، وإلا ما عملتي ميكس 4 3 2 مع بعض كان أحسن؟ أيهما كان أحسن؟
هو انا
كنتيجة.
اولا انا ما عملتش الميكس ده، ما عملتوش ليه؟ لان انا دلوقتي انا عايزه اعرف اللي موجود عند الفارمر نفسهم، هل اللي موجود عنده ده شغال ولا مش شغال، كواليتي ولا يعني جودته عاليه ولا ما عاليه. لو انا عملت ميكس مثلا عملت ميكس من 4 فحول عندي انا، هل هم زي سام اللي عند محمد في المزرعه بتاعته؟ هل هم زي سام الاربعه هم اللي موجودين عند خلف عند خليفه؟ مش هم، فاهم ازاي؟ ف I'm relying on individual samples.
كلمة عربي هاي قاعدين
ماشي. فانا بعتمد على فحله، بقيس الجوده بتاعه كل فحل منفرد، اوكي، لان في فحول حتى مش عارفين اسمها.
موجود كثير موجود. كثير
موجودين والله. 11 اللي عرفناهم سو فار 11
موجود
ماشي
كثير.
في حاجات كتيرة جدا
أفكر تعرفيني
مئات بس مش عارفينهم، حتى عاوزين نعمل لهم مولكيولر.
اظن تعرفيني من مسبقا، تعرفيني تشوفنا، انا مدير الارشاد كنت عارف، وانا بعمل دوره تدريبيه للمرشدين، محاضرات بالليل في بيوت الناس الكبار وبعدين انزل في المزارع.
تمام.
لكن عندما كنا نحطي بس نوع واحد كان احيانا يطلع شيص. لما دورت سبب عدم التوافق يحصل، لما تحطي 2 3 تخلط ما يحصل فيها شيص. هل كلام سمعتيه وعملتي تجربه عليه ولا بس المختبر؟
ميكس انا ما عملتش ميكس.
ما
عملتش تجربه على ميكس. احنا الحين في مرحله ان احنا نعرف.
طيب اللي عملتي فقط نوع واحد كان ما كان كامل الانتاج، كان عند الشيص، عندش عدم الالقاح، عدم الاخصاب.
انت بتتكلم على المرحله الثانيه، دي المرحله الثانيه ان احنا نجربه على الاناث بعدين، يعني نجربه في التلقيح. هذا لسه انا ما عملتوش. انا الحين في مرحله انا جمعت حبوب القح من المزارع.
سوري.
هذه المرحله الثانيه العين.
Okay. Thank you very much. It's very important to link the research with the application. Any more questions? Okay. Thank you, Dr. Zainab. Thank you.
I hope that we have him. Mr. Dr. Mohamed Amin. Is he online or?
Yes.
It's okay. So he can start when he yes when it's possible.
كده كويس؟ تمام. My name is Professor Amin Mohammed Amin Belmahia. I am from Algeria, University of Biskra. So I should start. طيب شكرا. Thank you very much. So my communication is about designing credible sustainability certification in date palm sector systems with a special focus on incentive integrity, ecological threshold, and feasible policy space. So the system is the wages system or palm date wages system is structurally vulnerable both ecologically and institutionally, as is characterized by the following production structure with dominance of small holders, heterogeneous capabilities, and fragmented supply chains. So the motivation of this study is that about the claim that the certification and ecolabels always or generally aims to internalize environmental externalities, improve market access, and incentivize sustainable practice. So the empirical reality we are facing here is that there is low adoption rates and outcome highly sensitive to monitoring quality. So the certification exists, but its effectiveness is inconsistent and fragile. So why certification often fails? There are two structural frictions. First, we have asymmetric information which lead to hidden actions by producer, and there are many nonlinear ecological thresholds that affect in degradation. So we have many risks such as certification without sufficient adoption, and there are always nominal sustainability with a real ecological decline. So we have certification, so the certification can legitimize unsustainable systems if poorly designed. So in terms of the current literature, we have the economic literature that focus only on incentives, and we have the ecological literature that focus only on threshold and resilience in ecosystems. So the missing integration here is that can certification generate enough adoption to maintain ecological viability? So the joint determination of incentive and ecological threshold is somehow underexplored. So the analytical contribution here is that is based on the fact that the mechanism design for framework is starts with heterogeneous producers and explicit ecological threshold constraints. The joint analysis of incentive compatibility and strategic compliance and ecological viability. Our paper here bridges the institutional design between ecological feasibility, between institutional design and ecological feasibility. So the model, as in terms of model structure, it is developed in length in the paper, but we have here a light version of it. So as starting point, we start with the continent producer indexed by cost parameter with two technologies, the conventional one with as baseline pay off normalized to zero, and the certified one with premium cost and fee. Heterogeneity is captured via truncated logistic distribution. Adoption depends on heterogeneous costs and institutional incentives. The four instruments highlighted in this framework is price premium, certification fee, monitoring density, and penalty of cheating. As the certification is a multi-dimensional mechanism, not single level. The incentive compatibility is when producers adopt if certified option is individually optimal and determine adoption rate. The non-cheating constraint is about the expected penalty that should be superior to the gains from misrepresentation and depends on intensity and penalty. The adoption and credibility are jointly determined in this framework. So we have the environmental pressure and sustainability condition that implies minimum adoption level through the following formula. with a level below this value, the system enters irreversible degradation dynamics. So as numerical exploration over the parameter grid, the four levers highlighted here, for each configuration, we compute adoption level and evaluate the ecological pressure each time. The feasible region satisfy the following formula. So we cannot land on the closed form solution, and instead the policy space must be mapped computationally. So we have the main results here, two main results that should be highlighted. This figure or plot issue of the simulation exercise shows that the problem is not simply to increase premium as usual, but the feasible space is limited. Once fees rise, ecological damage quickly exceeds the threshold. Once premium become too high, the mechanism itself becomes unfeasible. Certification is not broadly flexible. It works only where producers' incentives and ecological requirements overlap with a thin feasible region. The second result is shown through this plot where it makes the result more intuitive. The ecological viability is not a large valley but a small basin. Certification design must therefore be precise. Minor increase in fees or poorly calibrated premium can push the system back onto the high damage plateau, as illustrated in this plot. The sustainability corridor is not only narrow, it is geometrically fragile, so the instruments are nonlinear and highly interdependent. In terms of comparative statistics, we have the variation of the four highlighted levers or parameters in terms of ecological damage, where the certification instruments do not act linearly. Monitoring and penalties operate as threshold levers, while fees directly erode adoption. So as a matter of conclusion and the main policy implication, we can retain the following points. Certification must satisfy three conditions simultaneously: low participation costs, strong and visible enforcement, alignment with ecological threshold. The main policy implication of this study for the region are, we can state them as the following. Government should subsidize or minimize certification fees. More investment is required in monitoring capacity, and and policies should avoid over-reliance on price premium. The main conclusion is that certification is not a flexible tool. It operates within a tightly constrained institutional and ecological space. And thank you for your attention.
Thank you very much, Doctor Mohammed Amin. So the floor is open for any questions. I see no questions for you. So again, thank you for your presentation. Okay.
Thank you. Thank you very much.
Okay, so we have reached the end of our session. Date palm cultivation and the production highlighted the sustainability and value-added circular economy innovation across the value chain. We would like to thank all the speakers. We thank all the participants here, and of course we thank Khalifa International Award for palm date and agricultural innovation. Thanks, of course, for Dr. Michael for this. Thank you. Thank you, Dr. Mohammed Ismail, and for the technical assistance. And thank you all, and see you in the next conference here in United Arab Emirates. So I would suggest to have a group photo here.